Every automated machine from a factory conveyor relies on a simple, brilliant device to manage power: the contactor and relay. These devices act as master switches, allowing a safe, low-power control circuit to manage a dangerous high-power power circuit. The core principle is electromagnetism. We use electricity to create a magnetic field, and that field performs mechanical work, the key to industrial automation. We will focus primarily on the contactor, the heavy-duty version of the relay, which manages the massive current required by industrial motors. The contactor has two main sections: the coil assembly, the control input, and the contact assembly, the power output. The entire purpose of the contactor is electrical isolation, physically separating the safe control voltage from the dangerous line voltage.
Electrical pulse flowing into the contactor's coil terminal
is sent to the control coil. This current instantly generates a dense, focused magnetic field inside the cord into a powerful electromagnet. This magnetic force pulls the armature, a movable iron piece with immense force, closing the gap in the magnetic circuit. The armature is mechanically linked to the moving contacts. As the armature pulls in, it forces the moving contacts to change position. The core function of the switching is simple: connect the power flow. The moving contacts snap into the fixed contacts, completing the main circuit.
The coil power
stops. When the control signal is removed,
magnetic
the
flux
magnetic
instantly
field
disappears.
Instantly collapses.
The spring pushes the armature back up.
Pushes the armature
the coil
back
power
to its
stops.
resting state.
Magnetic flux instantly disappears. The spring pushes.
This spring-loaded return action instantly opens the power contacts, safely interrupting the flow of high-power electricity.
Digital control pulse.
This simple magnetic action ensures that control signals, whether from a small button or a complex
Digital
PLC,
control pulse
can reliably manage massive industrial loads. Contactor contacts are designed for heavy-duty switching. They are typically made of silver cadmium oxide, highly resistant to the damage caused by electrical arcing. The mechanism features both normally open no contacts, which close when energized, and normally closed NC contacts, which open when energized. When high current is interrupted, an electrical arc forms a superheated plasma that can severely damage the contacts if not managed quickly. To protect the contacts, high-power contactors
The arc is immediately forced into the arc chute plates above the contacts.
Similar to a circuit breaker, the arc chute uses metal plates to cool and split the single arc into multiple, smaller arcs, quenching the plasma instantly. Contactor coils operate on various voltages from 24 volts DC force-sensitive logic circuits up to 480 volts AC4 direct heavy industrial control. Additionally, contactors often have auxiliary contacts, smaller no-tensi, contacts used in the control circuit for interlocking and feedback signals. These contacts are essential for creating holding circuits or latching where the contactor remains energized even after the start button is released. This automatic control prevents large motors from restarting immediately after a power failure, ensuring worker safety and equipment protection. The contactor is the essential functional unit in every protective system. providing the necessary switching action for thermal overloads and safety interlocks. The genius of the contactor and relay lies in its simplicity and reliability, ensuring complex automated sequences are safely executed. It is the true power amplifier of the electrical world, bridging the gap between digital control, logic, and raw electrical horsepower. If this deep dive into the electromagnetic switching of the contactor intrigued you, please take a moment to hit the like button.
Subscribe to UA Electric for more essential 3D breakdowns of the complex systems that power our modern world.